Okay, good morning class. Welcome to Chemistry Honors with my group, Qn8, Lindy, and myself, Sean. Today we'll be looking at worksheet 6.2, question 8. So without further ado, let's jump right into the question. Okay, so this will be our starting product. And to start it off, what we'll do is Kleiser condensation. So we first start off by taking our base and deprotonating the alpha carbon on our carbonyl. Removal of the H, and this will cause the double bond to form and the electrons to go to the oxygen. Afterwards, we'll end up with this structure, our enolate ion. After which, the negative charge on the oxygen will go back, and then the double bond will actually attack this delta plus carbon on the carbonyl, and the electrons from the double bond will go to the next oxygen to give us our next product. Sorry. Afterwards, the negative charge on the oxygen will go back to this carbon and it will kick out our alcohol group. And this will bring us to our next product, which is the starting reactant for the next part of the reaction, which is actually our alkylation of the alpha carbon. So same thing as before, our base will deprotonate the alpha carbon. To give us our enolate ion. And then the negative charge will go back and our double bond will attack the methyl group to give us our second product in the question.
So the second part of the question actually involves the halogenation of the alpha carbon. So why this will happen is because, let's look at the molecule. So on this alpha carbon, the hydrogens here are slightly acidic in nature due to the electron withdrawing property of the carbonyl group that is adjacent to this carbon. So because of that, we can remove the H for to replace it with the halogen. So okay. So in this question, what will happen is that the oxygen will first be protonated by the acid. So you got an oxonium ion here. So what will happen now is that any base in the solution, such as OAC minus, will be able to deprotonate this alpha carbon, and the carbonium ion, oxalate ion will form. So yeah. So there's only one H here. Alright, so now this double bond can actually attack a Cl. So this is the halogenation step. Okay, then the electron will come back down to stabilize the molecule. So there's one hydrogen here. Okay, there's a thing to take note here in this question where usually if it's an acidic condition, it will only be mono-substituted because the releasing of this hydrogen will make the solution more acidic, which is not favorable because the solution is already acidic. So, but in this question we will just treat it as dye substitution will occur. Yeah. So the same thing happens again. We'll use any base to attack this H, and then get the oxalate ion. Sorry, the eno. And then this will attack another Cl. And the carbon. Yeah. So the lone pair will come back now. Now you have the dye substituted alpha carbon, and of course the last step will be just to simply deprotonate this hydrogen, and we'll get back we get our product. Yeah, so this one is our product for the third step.
So now we're at this step. So the first step for this last step is to substitute the Cl for OH via SN1 mechanism. So because Cl is a good leaving group, it will just leave and it will form a carbocation. So this carbocation is greatly destabilized by the electron withdrawing Cl and carbonyl group here. So water in the solution will quickly attack the carbocation. Then it will be deprotonated to form an alcohol. The next Cl will be kicked out and will form an oxonium ion. And this will be deprotonated again. And you'll get a ketone over here. So the next step, will be the hydrolysis of the ester group over here. So I'll draw the ester out. So this is the ester group. For hydrolysis, this oxygen will be protonated. And then water will attack. will be a proton exchange. So this alcohol will be kicked out, and the lone pair on O will give rise to another oxonium ion. It should be deprotonated by a base. You get the carboxylic acid here. So this is the hydrolysis step. The last step is decarboxylation. So in this step, because you have a ketone that is 2 carbons away from the carboxylic acid group, decarboxylation can take place. So basically, the oxygen will attack. You get the H, and then this electrons will move up, and then electrons will move here and here. Yeah. And so we have an enol here, and a methyl group, and carbon dioxide. So that's all. Usually after decarboxylation, you'll get a ketone, but in this case, the enol form is stabilized by this whole conjugated system over here with the carbonyl. So this is more stable, and so this is the major product.